Hi, everyone, and welcome to an AtScale live session. And today we have two very special guests, really good friends of mine from Databricks. So we have on the upper right is Franco Patano. Franco is the lead product specialist at Databricks, and he specializes really, I think now, Franco, right, in Databricks SQL, which is the brand new product that Databricks just shipped or just released, I should say. There's no shipping software because it's all a service, and it's pretty amazing. And Soham Bhatt is the lead solutions architect for Databricks, and Soham works on making sure people can migrate to the cloud. So he's your man when it comes to charting a course to the cloud. So hey guys, welcome to the session.
Thanks for having us.
Yeah, so I just want to plug that this is just a little promo, listeners, for our tech session that we have coming up on April 21st. It's April 21st, which I think is a Thursday, this Thursday, and it's at 2 p.m. Eastern, and we're going to do some really fun stuff. We're going to do some real fun stuff with tech. So today we're just going to chat about some interesting topics, I think, and really talk about what you're going to see on the 21st. So this is just an open session where we can talk about the Lakehouse, talk about the semantic layer, and really point you to some really awesome tech demonstrations that we have planned for you. So Franco, what do you plan on showing on Thursday?
Yeah, that's a great question. Thanks again for having us here today. Dave. I really appreciate it. Essentially, what a lot of people don't understand about Databricks and kind of what I consider it my goal this year is people don't really know that Databricks can do low latency, high concurrency serving of data out of the data lake. They kind of know Databricks as the big data science ML company. Obviously the Spark people is what we commonly get. And what I'm out here is saying we're not just Spark anymore. Spark is a big part of who we are, where we came from, but the world needs more than just Spark. We have then gone on to create Delta Lake, which is one of the fastest growing globally used data lake table formats, and also ML Flow. And then we acquired Redash, and we built this new product around it called Databricks SQL. And essentially, that's kind of what I'm out here showing people the value of, is essentially these SQL endpoints. And I know when we were first starting off on our AtScale journey, so Dave and I and Soham, we go way back. We've been talking about this semantic layer on Lakehouse, I think, since last year. And at first, Dave was like, I don't know if this is going to work. Your SQL endpoints, they're cool. But, we looked at the initial readings, and you're like, we're going to need some more. And it was great because we went back to engineering, and they basically took a lot of that feedback and they built a pretty decent amount of features in a short period of time. And then I think that's what we're going to go over, right? How can you build a semantic layer on Databricks SQL, and how performant is it? So I'm really excited to kind of work with you on that and kind of see what the results are.
Yeah, I'm excited to show, interactive queries. And now I say interactive, I'm talking about sub-second on Databricks SQL on a Databricks cluster. What I love about the Lakehouse architecture is that you write data once, and you write it to Delta Lake, and then you can apply and put different engines on it depending on what your workload is. You may choose to use Spark if you're a data scientist, but you're going to use probably SQL if you're a BI analyst. So it's amazing. It's really a real step forward to have a data platform where you can use the best engine for the job, but you don't replicate or copy data. So I just think that's a real game changer, and I've been super happy with the product, and it's lightning fast. So Soham, I mean, what does Databricks SQL mean for you, and for you taking customers on that journey to the cloud?
Yeah, it's very satisfying for me to see DB SQL out and in GA now, especially because I started my career as an ETL developer and then a data warehouse architect. So I come from the data warehousing world. And then after 10, 15 years of calling myself, I was looking at my resume, like ETL developer, ETL architect, data warehouse architect, and so on. And then on 2014, 15, I made that switch. I got Hadoop certified, and right. So for a few years, I was a big data architect, right? Like many of us here, right? We went from the relational RDBMS world to big data because of the issues of data warehouses not being able to do streaming, to do machine learning, and so on.
Mm-hmm.
And then I started doing Spark because even on other big data platforms, you use Spark. And then Databricks is the creator, original creator of Apache Spark. And so I was lucky enough to then join Databricks around 3 years ago. And when I joined for the first year or two, it was Spark, but with Delta Lake, it was a much better version of Spark. You can do asset compliance, insert, update, deletes. So it was an awesome engine for big data processing during my first year or so of Databricks. And then ML Flow came, so machine learning became super easy on Databricks. And then
Mm-hmm.
in the last year, I'm super delighted to see that now with DB SQL, we are not just a good data warehousing product, but we are actually the world's fastest data warehouse. We just won the TPCDS benchmark
Mm-hmm.
for data warehousing, which anyone can go to tpc.org and check out the results. So it's funny how the world went from like data warehousing to big data and then back to data warehousing again, but on big data, right? So that's what we call the Lakehouse paradigm.
Yeah, it's like you're taking me back now because since we started uh, since we started AtScale, we started on Hadoop, and Spark was our first SQL engine that we used on Hadoop. And when Databricks was founded about almost the same time, and what the big innovation was to put Hadoop or put Spark in the cloud. And I didn't really realize it at the time. It's like, okay, well, why wouldn't people want to manage it themselves? But we clearly saw that companies and enterprises trying to manage clusters for themselves, it's just they're not in the business to manage clusters. They're in the business to sell their products. They're not in the business to run a cloud. And so, Databricks and Databricks in the cloud and hosting Spark and making it so easy really, I think, was the big impetus to making machine learning and Spark so ubiquitous today. Is that you sort of took all the hard stuff of having to stand up a cluster and then keep it running, and you offloaded it to the cloud. And so that's a huge innovation. So Databricks SQL is just the next evolution of really spanning out and handling more personas to be able to process data in the cloud on a lake house or on a data lake. So it's very, very excited. So you guys should be very proud, and it's the future looks so bright for what we can do for a whole new set of personas.
Yeah, the interesting thing that I just learned was that you first dabbled with your kind of your semantic layer with Spark SQL. Is that about right?
That's right. Yeah, we were writing tickets for Reynolds. I filed a bunch of JIRAs early on, and complaining to Reynolds to get Spark SQL to work better. So yeah, we've been an early proponent of running SQL workloads on a clustered environment using Spark.
So
Yeah.
your first kind of semantic layer wasn't on a warehouse then?
No. So it comes back down to where my experience was. So at Yahoo, we invented Hadoop, and so I saw for right there that how difficult that Hadoop was not suitable at all for BI workloads back then. And then I went to cloud and basically ran into the same thing again. And we happened to be one of Cloudera's pilot customers, and it was actually when Cloudera came and showed me Impala that the light went on in my head that said that, okay, now there's at least a engine that we could run big data workloads on in a clustered environment. And so that was really the impetus to start AtScale, was that I always wanted to have that semantic layer, And Franco, I just chose Hadoop because that's where the pain was the most acute. And so we started there, but obviously, rode the wave to cloud data warehouses and cloud data platforms like Databricks, and made the platform work, universally.
That's awesome. So did I hear you right? You were at Clout, like the social media aggregator site that people were like comparing each other's social scores on?
So Franco, what was your clout score? You
I was
remember?
really low back then. And
No,
we're
okay,
talking.
tell me what low is. Okay, tell me what's okay. So the audience should know that your clout score, which is a measure of your social media influence, was between 0 and 100. And at the time, Justin Bieber was the benchmark. He was 100. So where'd you compare to Justin Bieber, Franco?
Oh, really low. Like at that time, I didn't have very much on my LinkedIn. This was like 10 years ago, right? Like it was a while ago.
It was back in 2013, 2014. Yeah, 2012, 2013. Yeah.
So about 10 years ago. Yeah.
Yep.
I was no one back then. I was still struggling with warehouses back then. I didn't even know about Hadoop. Actually, funny story. I bypassed Hadoop. I'm one of probably the only Bricksters that went from data warehousing and BI straight into Spark. Like I remember when I was no offense to Yahoo or whoever created Hadoop or anything, but during the sales pitch, they were like, and then we're going to write intermediary steps out to disk. And I was like, no, pass.
Yeah.
I mean, disk, it's like the slowest thing in the stack. Like, what do you mean you're going to write out temporary steps to disk? No, we're not doing that. How does this stuff process? Like, but this was big data. Like they were processing petabytes. So that was the only way that you could do it back then. But I remember I was like, there's no way I could get data warehousing and BI to work. There's no layer here for me to operate with to actually get good experience for SQL analysts. And I was like, I can't make this Hadoop stuff work. I did, however, get a pitch from one of your early salespeople. It wasn't you, because I remember you. But I remember, I'll never forget, I was at the Tableau conference in 2017, and I was running around the expo, right? And I was sent there on a mission. They were like, figure out what the modern data platform of the future is. Like, go interview all the vendors, and is this Hadoop thing going to work? And I'll never forget, I go by the AtScale booth, and you were making T-shirts. Literally, you had the printer and the hot press.
Yes.
You're right there, and you were making T-shirts, and I was like, "This is awesome! What is this company? I gotta talk to these people." Like,
that's why you want to talk to us, because we were making T-shirts. That's why. Come on,
I mean,
Franco.
wasn't that the whole hook? I didn't know anything about the tech. So then I talked to one of your salespeople, and like, it's the semantic layer for your Hadoop, and I was like, "What does that even mean? Like, do you know what a semantic layer is?" Like, I knew what it was, but I whoever the sales rep was, I apologize. I kind of made your life horrible that day because the booth was dead at that time, and I was just struggling. But I thought AtScale was. It's funny, before we kind of were prepping this, and we were talking about like how long it took to really take off. And I think you're an early innovator. You were at Clout. I think Clout was way too early for times. You do that today, everyone's going to want to know what their social media score is. I mean.
Yeah, what was interesting, Franco, was that, the reason why I was attracted to cloud was that I loved big data, but I also liked the advertising model, because you could use analytics against big data to really turn it into true value. And that was sort of always my draw into analytics, was that analytics paired with the right kind of business model could really generate a whole lot of value. And I'm a business guy. At the end of the day, I love business, and I love creating value, not just creating tech. What was interesting was that the score was actually kind of evil, honestly. I mean, my cloud score, I think, was 27. So look, and I hate social media. I really do. It's really hard for me to post stuff because it's just it's almost like bragging, and I was taught not to do that. So in any case, it's so I had to actually get involved in social media for cloud, because you couldn't have the VP of engineering for cloud have a bad cloud score. It was just not good. But the secret really is that we by people registering with Clout and giving us their tokens so that we could start to collect all their stream, their fire hose. That's how you basically got points and got a better score. And then you were subject to Clout perks, which were free stuff from different manufacturers and businesses because you were a Clout. You had Clout in a particular topic. Mm-hmm. So we had topics. We had all the different sort of demographic and psychographic types of data coming from Facebook. We scored half of Facebook at the time. Of course, wow. Then we had LinkedIn, we had Instagram, we had Twitter. So we had all the social media people, and we were able to bring those profiles together and get a complete view of your social media presence across all of those different social media systems and platforms. And that was unique. There was nobody who had that data. And so as a data geek, being able to apply machine learning to it, that's why we had Hadoop, is that we ran machine learning on it. But it was really that last mile of being able to do the analytics on the Clout audience that's where everything broke down. So I needed that semantic layer that was going to handle all this different dimensionality, because until I built a cube on top of Hadoop for Clout, we had no way of seeing an entire view of our audience. So all we knew at the time before that was that Justin Bieber was 100. And we didn't know how many hundreds we had. We didn't know if we had too many 20s, too many 50s. It was basically a big old guess. And so once we had that view of being able to actually do analytics on a billion people, and a billion people's profiles, social profiles, we were actually able to make that score at least look and behave like something that a data scientist would be proud of.
Yeah. And, it's interesting. Around 4 or 5 years ago now, when for one of my previous companies, when we did create a petabyte scale Hadoop data lake, Hugh out of Cloudera, you write
Hugh.
queries and it will, you remember that, right? It will keep
I remember Hugh. For the audience, Hugh, H-U-E, which was their SQL console. Yes, keep going.
So we evaluated the different vendors. I talked to AtScale way back then, 4 or 5 years ago. And we got you in. So you were our semantic layer on a big petabyte scale Hadoop data lake. And this was for probably a global Fortune 5 company back then. And so we I feel proud that at least we identified, this is the key piece missing in the Hadoop data
lake. Early adopter, I love it.
And the pain was exactly that, right? Even though we had Spark, thankfully, MapReduce was, who can do it except 5% of the Bay Area companies, right? So thankfully there was Spark. Thankfully, because of Renault Shin, he created not just Spark, but even data frame APIs. And so Spark SQL started gaining traction. And then I remember we got AtScale work on Spark SQL to get the performance that we needed. And tell me more about that, this whole idea of semantic layer on big data platforms, right? Because some of our customers will do ETL on Databricks, but they sometimes put the data out in a data warehouse. And then the problem they face is whatever the analytics they do, it's kind of on a stale data because the ETL from data lake to data warehouse is happening nightly or something, right?
So it's a common pattern, and it makes me want to cry, honestly, because we spend, as data engineers, we spend all this time carefully curating this awesome repository of data. And then that last mile, if you're a Power BI customer or you're a Tableau customer, you're shrinking it down to nothing. You're summarizing all the value away. And in Tableau, it's a Tableau hyper extract. In Power BI, it's a Power BI premium, which is basically analysis services under the surface. So you're taking big data and making it small. And to me, that's like a crime. It's like, why did we go and do all this work and assembling this amazing data asset if we're only going to look at 1% of it? And probably the most uninteresting 1%, because somebody had to decide what was worthy and what wasn't worthy. So you have somebody's opinion about what data is important. I think that's absolutely wrong. So, so that was really the impetus to say, why don't we give users, I mean, business users, data scientists, give the end consumers the choice of what they think is interesting and what they want to explore, and give them the tools where they can access that, but access it with the kind of speed and SLA that they've come to require, and without having to make the sacrifices of only dealing with the sliver of the data. And that's what I love about AtScale and the semantic layer on top of, Databricks and the Databricks Lakehouse, is that you can have your cake and eat it too. You don't have to decide what data is worthy. You don't have to do that early binding, where you're going to, create aggregate data and all the value away just to make it work in a BI tool or in a Jupyter notebook.
Yeah, that's interesting. So it's like enabling self-service analytics across your organization on all the data, not just the aggregated data, but structured, unstructured, all the data. And data scientists almost always will say, don't give me access to dev or QA, give me access to your prod data, right? They can copy it in a different place, but they need access to all the data to gain that value and insight. And even tie different data marts and data warehouses together to what I call to do pan EDW analytics, right? You could have multiple data warehouses, but like marketing data warehouse, sales data warehouse, and so on. But only when you put it together, all your data marts, your raw data, IoT data, and then you do analytics on all of it, that's where you get your aha ideas, aha moments, and you gain value using machine learning.
Awesome. Yeah, and Soham, it's like, that's a good example, because you have your marketing domain experts. They understand the marketing and marketing data, and also what it means in terms of the dimensions and metrics around that. Shipping team understands the shipping data. Finance team understands their finance data. So we really like the fact that it's a semantic layer. You can create these semantic models. You can let the domain experts define those models, but then you can bring those models together and like Lego blocks, right? And so you can see the full picture without having to know the full picture, because the person in shipping doesn't understand finance and the person in finance may not understand shipping. But if you can sort of put that knowledge together in that knowledge graph in that model, and you don't sacrifice the granularity of the data, then, sky's the limit in terms of understanding what's going on in your business.
Yeah, I often refer to as data warehousing as aggregating away the signal, because as soon as you do aggregates, you lose signal to noise, right? Any signal that was in that data is now gone because it's been aggregated away. And so it's useless for machine learning engineers. Give a machine learning engineer a warehouse, they're going to be like, I can't do anything with this. There's no signal here. It's all aggregated. Like you can't learn on aggregate data. And they always need access to the finer data. What gets lost, in my perspective, and one of the reasons why I really like the approach that you're taking here, especially with AtScale and Databricks, is that what if you could automatically, behind the scenes, understand what these queries are doing, right? And then create objects that accelerate the queries. But if you still want to look at the data, like you want to drill down, the data's still there. AtScale just kind of creates this efficient layer behind the scenes. You don't even have to do anything. Like it just kind of builds pre-computed aggregates, but it doesn't actually replace what was there, right? It just gives you like this performance layer. You want to drill down, you want to go deeper, you want to get the detailed level. It's all there. It's not like aggregating data in a warehouse. So I really like the approach that you're taking here. I do have a question for you. Putting a cube on Hadoop 10 years ago, that was a crazy idea.
Yeah.
So obviously,
it was a SQL Server analysis services cube too, Franco.
Oh, really? So you hooked up SSAS? I thought you built your own cube technology. Okay.
No.
So you took SSAS, pointed it to Hadoop.
Yes.
And you basically built cubes. That was the tech.
That's what I did at Yahoo, and then that's what I did at Clout. So first of all, what was good about that? What's good about that is you touched upon it, right? What you just said a few seconds ago, which is that you can't aggregate the value away, aggregate the grain, the details, and for our advertising business at Yahoo, the details were, okay, where did the ad show? What site was it? What was the placement? Meaning, what part of the page was it on? What was the format of it? Was it a banner on this, or was it a square? Was it a link? And then who clicked on it? Were they male? Were they female? Were they interested in sports? It's a highly dimensional problem. So what I did is that I put that cube on top of that data in Hadoop, and that generated $50 million of value just with that one cube. So the goodness is that by allowing our ad optimizers to get that sort of view of data, they were able to tune those campaigns and make a lot more money for our advertisers and for our publishers, and make a lot more money and for apps for Yahoo as well. But the problem, Franco, was that trying to pre-compute everything, it's an exponential problem. It's a logarithmic problem. And at the end of the day, it just couldn't scale. And so I still was left having to choose what data was worthy. And it was clear that the semantic layer that comes built into a cube architecture, that's the value, is the semantic layer, meaning measures, dimensions, hierarchies, the ability to do crosstabs and anything by anything. That is the value. The tech behind it was garbage. It wasn't garbage when it started. It was actually really good. It just couldn't scale to today's data. And so that's what we did. We said, don't throw the baby out with the bathwater, which is what a lot of companies have done, right? They said, oh, you don't need dimensions and measures anymore. You can just write SQL. And I just think that's a crime, because I think that, there's a small amount of people who can be proficient enough to ask a question in SQL. And our goal was to get data, make all data, like Soham said, available to everyone, not just a data engineer. And to do that, we needed to have a semantic layer on top of big data, and we needed to make it work. And at the time, everybody said we were crazy and we were never going to be able to make it work. And that's all you got to tell me, is that it's not possible. And I'll work extra hard to prove you wrong.
I hear you. When they told me you couldn't do data warehousing on a data lake 3 years ago, I was like, hold my beer. One question for you. One question about that whole story. How much did you mess with proactive caching before you got frustrated and started thinking about how to do it better?
You talking about in the OLAP world, Franco?
Yeah. So like SSAS, one of the things you touched on was like, it's a ON problem to keep this thing up to date, right? And one of the common ways that people in the SSAS world got like ability to stay ahead of it was to enable proactive caching, which actually brought up a whole slew of other things to actually keep track of, right? And it's like, I could just, in my mind, I was going back in time, my SSAS days, and being like, I wonder how much Dave messed with proactive caching until he was like, forget this, I'm done, we're going to do something else.
Franco, it didn't work because dimensionality was too broad. Yep. But when you get too many dimensions, then you have also the depth of data, because I don't know, that I think that was $500,000 just for that one computer, right? And I needed a couple of them because I needed failover. And then in terms of disk, I couldn't get enough disk, so I had to use Netapps, and Netapp SAN. So what would happen is that the way I had to update that is I had a cube A and a cube B. And cube A, while that was serving all the queries, I would be updating cube B with the latest data. And then what would happen is that when cube B's update was done, and I could do this twice a day, then I would do a swap. So I would do an IP swap so that now the traffic was pointed to cube B, and then I would start to update cube A. So that was, first of all, anybody who was querying cube A, when I did the switch, their queries would just fail, because it's like I had to cut them off at the knees. Nothing else I could do. And that was actually okay. People didn't complain too much about that. But that switchover was so scary that one of my engineers accidentally deleted one of the snapshots that we were using for our Netapp. And that meant that there was no data for that cube for a whole week. And why was it a whole week? Because it took us 1 full week to build that cube from scratch for 3 months of data. 7 days of 24/7 processing. So now I had the whole advertising business for Yahoo having no analytics for 1 week. So You want to know where the idea for AtScale came from? Well, it came from that very, very painful experience of having to, not be the most popular guy in the advertising business at Yahoo for at least a week.
This reminds me of, even in the data warehousing world, it used to take so long to load proper data warehouses, even if we had Netezza or Teradata, that we used to create a copy of the star schema or in business objects or Cognos, and same thing. After the load is done, we rename the tables to underscore backup, and the loading tables that we are loading becomes the live table. And like you said, everything breaks. Thankfully, with DB SQL's Delta Lake format, you don't have to do that anymore, because internally we keep like 2 copies anyways. So none of this happens. But so tell me this, in the webinar that you and Franco are doing, are you going to show us how AtScale can manage distributed cubes? I'm looking for, tell me how
for sure.
How do you make that one giant cube in one computer and make it work on in a distributed fashion?
Well, here's the thing, right? It's like the whole architecture is, we're always going to leverage the ecosystem. I call it standing on the shoulders of giants. And guess what? You guys are the giants. And we're standing on the shoulders of you. So we're standing on the shoulders of Lakehouse. That means that, don't try to be the compute layer. We don't want to be the compute layer. We want to be the router. We want to be the business, the intelligence router, and gets people the data they want. So the way we do that is that we take, we publish the semantic layer in a number of, we publish a semantic layer, and it can be consumed in a number of different dialects. If you're a data scientist, your dialect's probably Python or SQL, and you can talk to the semantic layer with Python or SQL. But if you're Power BI, it's DAX. If you're Excel, it's MDX. If you're an application developer, it's probably REST. So for a semantic layer to work, you've got to be able to handle all those different inbound dialects. And then, Soham, what we do is we take those logical queries, and we translate them to physical queries and generate Databricks SQL, and we let you do the work. So there is, I don't worry about scaling at scale, or our customers don't scale at scale. They scale Databricks. And they let Databricks scale Databricks. So that was always the idea, as like, I don't want to be in the scale business. You shouldn't have to scale your analytics platform. You just need to scale your data platform, and then your analytics should scale with it.
Awesome. So Databricks SQL endpoints will scale up, scale down when there's not going on. And you guys, what I loved about AtScale is you parse the queries that customers are writing, and you figure out whether a cube or an aggregate is needed or not. So people don't even have to predefine all the materialized views, right? Because you do it for them. So in that sense, you are almost like auto ETL, creating materialized on the flies, and you analyze, no one is using some of the cubes, so you delete them as well. That's fantastic. Awesome.
Yeah, and it's even though it may look like a cube to a tool like Power BI or Excel, it's not a cube at all. It's a set of aggregate tables, and those aggregate tables are delta tables stored in Databricks Lakehouse. So the data never leaves the platform, and that's the other part, right? It's like, you don't want data leaving the data platform. You spend all this time not just curating this awesome data set, but also securing it. And then now it's going to go and like fly away into somebody else's system who you don't know what the security model is. And it doesn't matter, because it's another security model. So the whole point is to secure it once. And if you secure it once, then you should be able to read it many. And depending on who you are, if you're in finance, with the AtScale semantic layer, you're going to see the finance fields and revenue fields. If you're an HR, you can see social security number. But if you're in marketing, you're not going to see, revenue or social security numbers, because you don't have rights to see that. So you should be able to secure that once in one place. And that's really the value. That's really the extra added value of going for an integration first approach versus trying to do everything ourselves.
So if I understand you correctly, then if your system utilizes the underlying compute, so as Databricks makes Databricks SQL endpoints more efficient, your processing, kind of your refresh process, actually will get sped up as well. So by leveraging the kind of the standing on the shoulders of giants, if you will, as like the whole stack improves, it's kind of like it just goes all the way down. It's improvements all the way down the stack, which is really nice. One question to you is, so we heard that refreshing how many hundreds of terabytes took a week rebuilding it back then.
24 terabytes, Franco.
24 terabytes. What, yes. What is one of the biggest cubes you've seen at scale today? And then what's the typical loading time with today's kind of compute technologies? I don't know if you've done one on Databricks SQL, but just in general, what's the difference so we know just like how much this technology has matured over the years to do like a 24 terabyte cube nowadays with that scale?
Well, so first of all, we don't have to build a cube. So we don't have to actually do any pre-processing. So as soon as I define a semantic model and I publish it, we're querying in 1 second later. And you're querying live data. So that's very different from the architecture of old, where you pre-calculate and you build a cube before you can actually query it. So, but it's about aggregates, right? And refreshing the aggregates. And so we're refreshing the aggregates behind the scenes whenever the data changes. And so a good rule of thumb, like actually, I just did a benchmark on Databricks SQL, and we did 10 terabytes, right? For the TPC DS, we used your data. We did your test, 10 terabytes of TPC DS data. That's about 55 billion rows of data. And we can update aggregates in less than 20 minutes for a full refresh. So not even an incremental refresh. So rather than it taking 7 days to do 24 terabytes, we can do 10 terabytes in 20 minutes. So, and that's for a full refresh, which you never do. You only do an incremental refresh with the newly added data. So it's lightning fast. And the queries against that are fast or faster than what we got out of analysis services. So that's really the state of the technology, is that, again, keep the good stuff, the semantic layer, toss out the bad stuff, the physical architecture.
So what you did was basically take all the definitions of the semantic layer, and then you built your own backend, basically just almost like just-in-time semantic layer, where it will build the objects as they're coming in. So the reason why you can query it right away is because the protocol in which comes over the wire, you're interpreting the kind of the cube command, but it will build the constructs kind of like as you're querying it. So you don't have to do like something like a proactive caching or figure out your schedule on when your cube is going to refresh, because it's always working in the background. Is that right?
That's right. Yeah. So we're creating aggregates on the fly based on user query behavior. So Franco, if you come in and you say, I want to see, I publish a model and it has 10 different dimensions, and of those 10 dimensions, you say, show me revenue by region for last month. That's basically 2 dimensions and 1 measure, right? So revenue is the measure, time is, and region is other 2 dimensions. And so based on that, we'll create a reusable aggregate table based on those dimensions. But we'll do something better than that. We won't just say it's not a query cache. So we don't just say we're just going to do the Franco query and make that a table. We'll actually see what's around it, and when we'll create an aggregate that's going to be much more useful than just that query. So if you're not just asking for region, you're asking for you asked for, I want by country, which is a region. And then I want to drill down to a state, and then from state to city, and then from city to zip code. That's all going to be satisfied by that single aggregate. And if I want to go by time, I don't want to just by last month. I want to do it by quarter, and do it by quarter back to 2015. Again, that aggregate is going to serve that query. And by revenue, I don't want revenue. Now I want gross margin as well. Again, that aggregate will serve that. So we're really smart about, you say proactive caching. We're very smart about proactively understanding the intent of the query and then expanding it and creating an aggregate structure, an aggregate table behind the scenes, a materialized view that's going to be much more useful and than just what you asked for.
Almost like proactive aggregating.
It is. It's exactly what it is.
Awesome.
And it's not just that. We don't have to wait for your signal, meaning a query. We also know by the structure of the model. So that we can actually proactively build aggregates based on things like when you build a dashboard. When you're building a dashboard in Tableau, you can imagine you're dragging over dimensions, and Tableau is filling in all the values in that dimension. So if you drag over, let's say, country, that's going to show you all the different countries in your world. Well, that's a distinct query that has to be generated against the platform. And if you're dealing with, like our customers have literally hundreds of billions of rows, that means that's going to be a query that's going to do a distinct on country against 100 billion rows. You can't build that dashboard because that query is just going to time out in Tableau. What AtScale will do is we'll understand that's a dimension, and we'll have that ready and set and serve that from an aggregate. So so in instant one, when you're building that dashboard, you're going to have lightning fast performance because we already knew what you were about to do.
That's interesting.
Yeah. Awesome. Tell us.
We're geeking out here, guys.
I think that's excellent. So essentially, you kind of like parse the model, and then you're already aggregating your dimensions. Because I can't tell you, like, it is a super common task to count your dimensions, like, and you just kind of know that, and you're like, all right, you know what? So it's like the industry experience, not just the industry experience, but the business experience that you have with these things that you implemented into the model is kind of the real value proposition here. Is that you've been designing these cube without a cube, let's call it semantic layer, right? But cube without the cube technology. Like, how would we rebuild this thing from scratch using modern technology? And you're like, what are all of the things that I liked about it, and what are all the things I didn't like about it? Kind of like what we did with Lakehouse. We knew we liked databases and warehouses. We knew we liked data lakes, but there were things we didn't like, and we kind of brought the best of both worlds.
Yeah, yeah. I mean, nobody likes to load the data warehouse, right? So you've like taken away the loading of the data warehouse. That's freaking awesome. Isn't it? Who likes to load it? You don't have to load it. You just want to be, when it gets written, you want to query it instantly. Just on your point, Franco, like that, the reason why we know to do that is that if we just had a bucket of tables, you had just a catalog of all these raw tables, we don't know what the dimension is. We don't know which columns are what. So we don't know what to do. But when a subject matter expert says that this is time, and this is my hierarchy that I want to use with time, and this is where my location is, and this is the roll-up we want from our location, they told us everything we need to know. And so it doesn't work without the data model. So if you can't just take a raw set of tables and think that somehow the machine can work it out. We're working on that. I'm working on that so that one day we don't need the human to build a semantic model. But darn it, we still need humans because they're pretty smart about being able to help us identify what's interesting and what's not.
So one of the questions I have about your product, we've been talking about business domain and how this technology really needs to enable the business to do what they need to do. Almost like, as technology practitioners, it's our goal to give them the tools they need to get their job done, and they don't even know our name, right? Like that would be like ultimate success, is if I could just implement the things and they're off and running and they're being successful in the business. They're making great business value decisions, kind of like they did back in Yahoo with ad optimizations. Who knows what it is? Looks like we're running out of time, so this could be one of the last questions if we're running out of time. But who uses AtScale? Because I'm a technology practitioner. A lot of times cubes had to be built by an engineer, right? Like you needed to hire like a consultancy to build your cube, or engineers and developers to build your cube. When you're talking about like AtScale, it kind of seems like these aren't engineers. These are business people going into the UI and building these models. Can you talk a little bit about who uses AtScale and kind of like how that works in the product lifecycle and delivering business value?
Yeah, that's a great question, Franco. And you touched upon a couple ideas here. First of all, there's the author of the model. There's a subject matter expert, the SME. And so it goes back to that whole, the shipping, the people, the business unit that owns shipping or the finance team, they understand their data, they understand the shape of the data, and they understand what revenue is and what gross margin is if you're in finance. So it's up to them to create that semantic model because they're the domain expert. So if you take that whole data mesh concept, they're the domain owners, and so they can create and they can use that semantic model to express their business logic, and that's how they can share that business logic with everyone else. So they're the publisher, they're the author, and then you have the consumers, and the consumers can be a business analyst as a persona, it could be a data scientist, it could be an application developer, and they're the consumers. So you can think of it as like when you create data products, you have the subject matter expert who's adding their knowledge to that semantic model, and that's the way they communicate with the rest of the business. And then those subject matter experts can then put together those domain models to create composite views. So you have even more power into seeing different interactions across the business without, again, having to understand the whole business. So there is no shortcut. You still need to have somebody, a subject matter expert, in the equation, but it doesn't have to be a data engineer, Franco, to your point. It can be a business person who's going to use a UI to define or code, if they're more comfortable, to use their knowledge and to express it as a model and share it with others. So I think it is author once and it's use many. And that's what it is. Yeah.
And this is a great question by Franco, right? And a lot of time people sometimes come and say, well, everyone will write SQL. I don't think that's practical. A couple of reasons, right? When you have thousands of tables, or even within your subject area, you got to understand the relationships between them, right? So the concept of modeling relationship hierarchies definitely help. But some real life examples, right? So for example, I work for some pharma companies and they have thousands of medical pharma reps, right? Their job is actually sales. So they have to go and visit doctors, drop the drug samples, figure out whether the doctors are writing their prescription or someone else's, and so on. Mm-hmm. And then to do their job, they need to see the data, right? And they're not SQL experts. They are like traveling, meeting doctors, and so on. So in this particular example, they have a dashboard from like our data warehouse where they will cut across the dimensions of, it could be region, drug, doctors, their specialties, and so on. So mm-hmm. they use the semantic model to make decisions to get their job done. Same thing, look at all the warehouse workers in some big companies, or there are restaurant companies with thousands of restaurants, and the managers want to either input some data or look at some mm-hmm. reports, make some decisions, right? So semantic layer need is super real. And while the business analyst and the data engineers can write SQL, this is one more layer of abstraction on top of it, which makes the data accessible for the entire company. So it's super important concept, which we shouldn't forget when we build a modern data stack.
Yeah, and when you look at sort of the combination of our two companies, right, where when you have a great platform like Databricks, where you're able to take data from collection and put it into a repository in a lakehouse, and then you have the engines and tools to be able to do super fast queries against that lakehouse, then we're the sugar, right? Or the semantic sugar that we can sprinkle on top to make, I think, a really delicious dessert. Oh, sorry for that. I love that. Sorry for that analogy to everybody.
No, it's awesome. Semantic sugar. I love it. I'm using it. Well, I've got one last question. After I just heard you guys talking about that, something just clicked in my head. So what you're saying is with AtScale, that you can have domain SMEs, domain subject matter experts across your company. And essentially, they're enabled with your software. They can put all their business knowledge for their expertise into the software. And then somebody else can use it. But not only that, I think I would want you to show me this maybe in our webinar. How do you connect? Can you connect up maybe like the models from across the organization and bring them together? Is that possible?
Absolutely, because you have a library of models. Mm-hmm. And those models can be joined together with conformed dimensions. This is your old Kimball days. So this is what kills me. It's like we can't forget about this stuff. These are important concepts, And a conform dimension is time is the most common conform dimension. So everybody reports on time. So I can take my finance, which is on my revenue, and I can take my shipping details, and I can go ahead and lay them side by side and connect them up just using a time dimension, because that's the conform dimension. And that's the glue that allows you to connect these Lego blocks of these different data models, which were authored by different SMEs. Now SMEs can then join those models and those views together with their own models and create composite views that really replicate the business, create that digital twin of the business that everybody always likes to talk about, but do that with software.
That's awesome.
Yeah.
Awesome. So it's like Databricks is that 3-layered cake with bronze, silver, and gold, and then you sprinkle some AtScale sugar on top.
I like it. I love
layer.
I love it, Soham. I love it.
So awesome! This enables us to do data warehousing directly on the Databricks Lakehouse. Awesome! Looking forward to this, folks.
Yeah, it's going to be a fun session. We got a jam. We got a jam. So look, everybody, listeners, please join us on Thursday, April 21st, 2 p.m. Eastern. And Soham and Franco, thanks so much for joining. And Franco, it's going to be fun. So let's go geek out and show everybody what we can do together.
Thanks for having us, Dave.
Thank you.